So in the previous lessons, just a little bit of a recap before I get going, we spoke about the sine rule. Okay, so we spoke about something called the sine rule. We had that. And we spoke about something called the area rule. And these are very, very helpful in certain situations to help you find sides and angles in the case of the sine rule. And in the case of the area rule, normally you find the area, but you can also find sides and angles using the area rule if the right information is provided. Now, these tools are very useful because they don't just apply to right-angled triangles, they apply to all triangles. Okay? And that's what's so new in grade 11. You're learning to be able to find sides and angles in triangles that you wouldn't have been able to find these sides and angles before. However, I've only covered certain types of situations. I haven't covered a situation like this. So say, for example, I have a triangle and I give you, let's say this side is 11, this side is 14, and let's say the angle in between these two is, maybe it's 40 degrees. I would suggest to you that we do not currently have a way of finding this side length over here. And the reason we don't is that we don't know what the area is. So we can't use the area rule to help us. And we also don't have a matching pair of sides and angles. So when we use the sine rule, we normally need to have like a side on the top and the sine of an angle below, and then another side and the sine of the angle below, or something to that effect. The problem here is the angle is facing the side that we don't know. And the same with these sides, we don't know those angles. And so we can't use the sine rule. What I want to ask you as you start tonight with me is, do you understand? Give me a thumbs up if you understand why you can't use the sine rule to find the green squiggly bit here. So thumbs up if you understand why the sine rule is not cut out for the job for this situation. And thumbs down if you're like, what is going on here? Okay, so what we need is a new tool for the job. We need a tool that helps us find an unknown side if we've got two sides and the angle between those two sides. And that tool is called the cos rule. Now, why the cos rule works requires a formal proof. I'm not going to cover that tonight. What I'm going to cover is how to use the cos rule. And so that's going to be the focus of today's. So for Tejo, the reason we can't use the area rule, we could use the area rule here to find the area. Okay, so we could find the area using the area rule. That's no problem. But we can't find the length of this side over here is what I meant. So you're right, you could find the area of this because you've got two sides in the included angle. Okay, so let's talk about the situation of the cos rule. What does it actually mean and how do we use it? Now, the way it's generally written is like this, although that still looks a bit confusing. So what we have is we have something squared equals something squared plus something squared minus 2 times 2 somethings times the cos, sorry, my thing, what's the name there, times the cos of some other thing. So that looks like quite a mouthful, but what I want to suggest is the cos rule says, do I have two sides and do I have the included angle? I do in this situation. And so what the cos rule says is, it says in this case, BC squared, so that's the side that I don't know and I want to find, BC squared is equal to, the two, I call these arms, is going to be equal to 23 squared plus 20 squared which are basically just these things over here. Then over here, I'm going to write 23 times 20, but there's a minus 2 in front. And then at the end, I'm going to write the cos of the angle between the two sides, which is 55. I want you to take out your calculator and find me the value of BC squared using this cos rule thing that I've just suggested. And again, this first round is just getting used to the feel of how this rule works. It looks a little bit like Pythagoras. It's just got this extra bit added on the end here, which we need to get used to. But I want to know, what is the value of BC squared that you get? So I'm going to say 23. Let me see what's going on in the chat. We're getting 401.309. So 401.3096, blah, blah, blah. Now, I don't want BC squared. What I really want is BC all by itself. And so what I'm going to do is I'm going to use a trick on my calculator. What I really need to do is square root both sides, but that would take a little bit of extra time. And I'm just going to use the answer. So at the moment, this value, if I clear it away and I click answer and I go equals, that value is stored in the answer key. And so all I'm going to do is I'm going to go square root answer, and then I'm going to get my answer, which is 20.03 centimeters. So if I've got two sides in the included angle, by using this thing called the cos rule, which admittedly at the moment it still looks a bit weird, I can find that third side. So I want us to initially tonight just practice getting this right. So I'll leave this up on the screen, and I want you to try and use the logic or the method that I'm showing you here, but apply it to this second triangle here, where you are trying to find, for me, QR. So you are trying to find QR, which is this unknown side here. And you've got this side, you've got this side, and you've got the angle in between those two sides, which is a good news for the cos rule, or at least for trying to use the cos rule. So over to you guys, work out what QR is. Kia, if you could just help Kimmy and Casey there. I think they're having some problems with hearing, and there's probably a set of instructions that they can follow to just help them. Okay, for Zama, let's see if I agree with you. I haven't worked this out yet, but I'm going to start with the kind of learning the general structure of how to use the cos rule. What is QR going to be equal to? I'm going to use my calculator to help a little bit. So 3 squared is 2 times cos 67. And then I must just remember that isn't QR itself, that's QR squared. To get QR, I need to go square root answer, and it looks to me like I get 8.49 centimeters. Okay, give me a thumbs up if that worked okay for you. Give me a thumbs down if you found that a bit tricky. And again, remember the rule is we're just applying the cos rule at this stage. We're just getting used to a new tool. It's like we're learning good technique for using the cos rule. Okay. How about we do one more, just checking that we know how to use it, and then we can move on. Find me the length of QR for this thing over here. And again, the good news is we have the right situation for the cos rule. We have two sides and the angle in between those two sides. And that is what the cos rule is sorted to solving. What do you think QR is going to be equal to? Who feels like they've got it? Okay, so and when you feel like you've got something, pop it in the chat. So what I see is I see an answer of 12.22 centimeters, which is that length over there. Okay. So the good news is at the moment, the cos rule is helping us find unknown sides, and the unknown side that it helps us solve is the one that basically is opposite the included angle. Notice how the side that you're solving for is always opposite the included angle between the two known sides. And that will become important a little bit later. So I just want to point that out for now. That relationship between the unknown side and the angle that you do have. Okay. Cool. I like what I'm seeing, Sonic and Owami and Nompilo. It looks to me like things are going swimmingly. I could be wrong, so let me know in the chat. But I think it's time to have a multiple choice question to, just mix it up a little bit. So tell me which of these four options is correct in terms of writing out the cos rule. Which of these four do you think is correct? So ask yourself, which is the angle between which two sides? Which is the one that's going to be by itself? It looks to me like x squared should be by itself. So I'm going to cross out the A to start with. Must be one of those three options. Which one fits the description best? So I kind of know the way this works is I take the two arms and this angle in between and I go 12 squared. Okay, let's just keep it on mute all if we can. I don't know why we. Okay, mute all. I just hit mute all there. And then what else do we have? So 12 times. It looks to me, in fact, I'm not going to finish that because I can see what the answer is going to be. It's going to be. It's going to be this one, which is C. Over here, because this one doesn't have the 2 and this one has the wrong sides. Cool. I like what I'm seeing in the chats. I see lots of C's and I'm pretty sure everyone is confident. So what I'm going to do now is I'm going to give you a slightly harder question. Okay. And I'm not going to say much. It's still a cos rule question, but you have to think about how to apply the rule more deeply. Okay, so here is your question. Which of the 4 do you think matches the correct writing down of the cos rule? And I'll give you some time to ponder this. And I'd love it if some students, as they're looking at this question, could write some of the thinking, or maybe they could give us a comment about what they notice about this question. Why is it different? Why is it more difficult? What do you notice? I'm curious to know what you notice compared to the other ones. Tiboko, what do you notice about this that makes it a bit more interesting? I would call it more interesting.
Hi, sir.
Hey, what do you notice?
With this triangle, there is no angle between 11 and 9.
Yep. You almost want it to be here, but it's not there. So what does that mean?
We're going to use the angle between x and 9.
Perfect. So these are like the 2 arms, and this is the angle. Do you know which one to write by itself? At which side to write by itself?
11 squared is going to be by itself.
Yeah, because it's opposite the angle. Thank you so much, Tiboko. You are on fire. So now it's a question of how do we know which one is next? But following this logic, it feels like this has to be a 9 squared and an x squared. And this has to be a 2 times 9 times x, just following the pattern of what we're learning. And there also has to be a cos. And now what is the angle that's going to be involved in that cos? It's going to be 44. That's what I get. Now, which one of those 4 options is going to match that? Okay, so that sort of looks on the right track. That one can't be because there's no 2. So that's out of the race. This can't be. And now it's a question of either this one or this one. So either B or D is the one. Oh, but I noticed D has an x squared by itself. And so the correct answer must be that one, B. Give me a thumbs up if you followed that. Give me a thumbs down if you are feeling a bit unsure, because that should have been harder to do for you. And so I just want to check in that you are still feeling good. Okay. Clearly, you guys are quite good at cos rules. For those who are feeling a bit lost, I really just want to focus you on the fact that look at the 2 sides and the angle between the 44. Now look at the side that's opposite. That's normally the side that you're solving for. It's just that in this case, that is the unknown. But when you write out the cos rule, you need to write that 11 by itself. And then the other relationships stay like they are. Okay, so what we have now is why we're still I don't know why the muting isn't working. Huh. Okay, let's do one more. We've still got 2 more questions actually before the break. So let's try and do this one. Which of the 4 do you think is correct here? So we have 4 options. We have our triangle, we have our 2 sides and the included angle, and we want to try and find x. Which one do you think is correct? So remember, this is the angle we've got. It's normally this one that's written by itself. So we're going to get but what we want is x, and so x has to have a square root over all this stuff. Now, which of the 2 looks correct? Well, this is for grade 10 trig, so it can't be those 2. And the thing that I know this can't be right is there's a plus 2 times where there should be a minus 2. And so that should be the correct answer. Okay, before we have a break, because that looks like, from what I'm seeing in the chat, yeah, and there's also a -6 in D. You're quite correct. And so the -6 wouldn't work. Let's do one more question and then we're going to do a break. So what you're going to do is, here is a triangle, and there's a bit of revision from the previous lesson. You are going to find me the area of this triangle, and you're also going to find me the length of YZ. Okay, if you are feeling confused or would like to have a conversation about this, please put your hand up and we can chat further. Otherwise, give it a go. See if you can do 1A and 1B. I'll remind you of the structure of the area rule and the cos rule. And then this one would be those are the structures you're going to have to use to help you. What do you get for the area? Remember area, how much space fits inside here? Guess this is going to be YZ. And then this one should be 8, 10, 79, 8. Notice how the area rule has a sine in it, whereas the cos rule obviously has a cos in it. That's also an important distinction. So let's see those answers coming in. Tova, that looks good to me, Tova. And Akonele, 39.27. So you should be getting 39.27 centimeters squared for the area. And for the length of YZ, you should be getting 11.55 centimeters. Okay. As I look through the chats, I see Fazama agrees, Lebo agrees, Kevin agrees, Ongani agrees. Looks good to me, hey? Letty agrees. Letty, I see there's a little bit of rounding difference, but that's just because you probably didn't carry the decimal places. Nompilo agrees. That's fantastic. Okay, I'm very impressed by what I see. I declare it halftime. It's time for a break. And so what I want you to do is I want you to stand up And I want you to feel the joy of just standing up on your two legs away from your desk. If you could just turn on your camera so we can all see you, that'd be awesome. And let's start by just, let's just shake our arms out, or let's just swing our arms a bit. And while we're swinging, we're going to look off into the distance, and we're going to let our poor eyes have a break. We've been focusing close in front of our face. We want to look off into the distance. And then let us stretch while we're still letting our eyes rest by looking off into the distance. So we can stretch like this. Oh, my shirt feels a bit tight. So I'm not really stretching properly, but anyway. Okay, and then let's roll our shoulders. Roll our shoulders back. Let's roll our shoulders forward. And then let's shake out our arms again. Let me shake them out. Shake out your legs. Make sure the blood is circulating in your body. Let's stretch our necks. So you should feel a little bit of a tightening to the right. So if you just go like this, give your neck a break, then switch to the other side. You should feel a bit of tension here, but like a good tension. And then let's take 3 nice deep breaths. One more, or 2 more. One more. Okay. And then let's finish by getting our blood pumping. We're going to do 30 air skips. And we'll start in 3, 2, 1. Let's go. 2, 3. Halfway. And we're done. So I hope that your body feels a bit alive, and that you feel like oxygen has kind of spread throughout your body, and you have just had a bit of a break from all that hard work. So here is our puzzle for today. Can you tell me, Rafense, that's inflation, huh? That's how it goes. You gotta keep the edge there. All right. So I want to know, what do you think is going to be the value in that block over there based on the pattern that I have shown you? What do you think is going to be the number that occurs there? What do you think is going to be there? So I see a couple of different values. There's actually a couple of different patterns that could work here. So some people have said 11. So this is going +3, +2, +3. I'm not sure I get that one. What I was thinking, but there could be different ways of doing this, is like 4 squared is 16, 7 squared is 49, 11 squared is 121. But clearly they're not writing the full thing down. So what I was thinking, but there could be other ways, is 6 and then 9, and then the next value would be a 1. But I think there are other ways of doing it. So who would like to maybe offer an explanation of how they got their value? There might actually be multiple answers, but who would be willing to share their thinking around how they got their answer? Just pop your hand up and we can unmute you. Who has an idea? Like, how did you get, so you add 2, you add 3, you added 1. Yeah. 13. How did you guys get 13? Who would like to offer an... Okay, let's go to Kimmy. Kimmy, how did you get your answer? What was your answer? So Kimmy, if you, and Casey, if you look and there's a little button at the bottom, you just unmute yourself. If you, I'm currently asking you to unmute, but I'm not sure if you can see that on your side. Okay, maybe we're having some audio issues there. I am curious to know how we got 13. Plus 3, plus 4. Okay, so this is plus, seems to be going up in plus 1, plus 2, plus 3, plus 4. So I see that pattern. But now, I suppose I'm adding 2. I'm not adding 4 here. So what? Okay. I think maybe, Fatejo, maybe you can tell us what your thinking is. And then we're going to move on back to the lesson. Can you hear me? Hey.
So I got 13.
How did you do it?
I don't know about the one, but I said 2 squared, 2 plus 2, which is 4. 4 squared, 4 plus 2, which is 6.
Okay. 4 plus 2. So you took this and this to get there.
Yes.
And then?
4 plus 2, which is 6. And then 7 plus 2, which is 9. So 11 plus 2, which is 11. I mean 13.
13. Maybe my brain is just being a bit thin today, but I'm trying to see the pattern aspect of what you're saying. 2 plus 7 is 9. 2 plus 4 is 6. Oh, I see. 7 plus 11. Then would you not get like 18
no,
or
sir,
something?
you use the exponent and you add the base with the exponent.
Oh, yes. Now I see it. I see it.
I don't know about the one, but the rest, yeah.
Okay, cool. No, I see where you're coming with that. Thank you for your ideas there. Okay, everyone, I hope that you had a bit of a break. I hope that it feels like you're ready for the second half of the lesson. So let's go back let's go to a question like this, where we start to extend our thinking. So I want you, and this is where we're going to have to help each other. We're going to try and find what AB is. But we've got a pair of triangles that we need to start with. And so I'm going to let you have a go at this. So the goal is to find AB, but maybe those who are feeling like they've got ideas, they can put them in the chat or they can come online and give us some suggestions. But for the most part, I want you to try and think about how would you find AB using what you've learned tonight and what you've learned in previous lessons. What do you think? What do you think is, and we love tips from our community. So do a friend a favor. And Fatejo has suggested, she thinks finding BD would be a good place to start. And Fatejo, I think I can kind of see what you're going for there. And I think you're on the right track. Lebo agrees. Lebo says to find BD would be good. I think so. Yeah. So let's set up looking for BD first, and then we can go from there. So I'll give you some time for that. Hmm. If you let me show my whole screen so you can see the. Also, no one can see me at the moment, so. Here, can you see my face now? I think my camera was off. Okay. So what did we get for the answer for this one? Plus 5 squared minus 2 times 5 times 5 times cos 47. And then we need to go square root that. And we get 3.99. Let's call it centimeters, although. Okay, now we've got this bit over here. Any ideas of where we go off? Should we just, you know what, everyone, I'm going to make an executive decision. Let's round off BD to be 4. It's just going to work out more easily. I know technically it should be 3.99, but I'm going to use my teacher powers for good and make those 4. So now, who has some ideas about where we go from here? Any ideas? Because remember, we're trying to find AB, which is the yellow one. The sine rule. Tato, I think you might be onto something. To find AB, can we use the sine rule? Well, let's have a look. If we use the sine rule, we'd write the side AB over the sine of the angle opposite. But the problem is, I don't know what that angle is. So I feel a bit stuck at this stage. So maybe we shouldn't find AB. What should we rather find? So maybe what we should do is find well, we need to find this angle here, yes. But maybe instead of finding that one, maybe we could find this one, and then we can use this one to find that one. What do you think of that idea? So I was thinking, we could go, well, maybe we could use the cos rule. So we don't know what that is. We don't know what the blue one is. What's wrong with the sine rule? Okay. How about, would you follow me if I wrote the sine of B, or maybe I should even write the fancier way, the sine of ABD, which is this red dot up here, over 6 is equal to what? What is the sine of ABD over 6 going to be equal to? What would make my life a bit easier if I'm using, maybe you can see where I'm going with this. We can find D using 6 and 4. I don't think we can find D using 6 and 4. So I think we should go the sine of 45 over, so sine of 45 over 4. Yes, Bonga Corsi. Okay, so you can see how these questions become a little bit more intricate because of this. Now, I want you, remember sine of ABD, let me just take this away. I want you to try and find me what this green angle is here. And this is going all the way back to lesson 2. Can you find me what this angle is here using the sine rule? And Fateko, I see your hand is up. What's your question? Why sine 45? Because if you look, we have a 45 over here. And what is the side that is opposite 45? It's 4. And so the sine rule says the sine of an angle divided by the side opposite is equal to the sine of another angle, which is this opposite, whatever, divided by whatever is opposite it. Don't worry, Letty. We're taking it up a notch in the second part, but we're going to take it step at a time. The end goal is to find AB, okay, but we're not there yet. So what we can't find AB, okay, because we don't have a way of getting to the yellow yet. So what I'm doing is I'm saying that the sine of this angle, maybe I should use green, the sine of this angle over 6, which is given, is equal to the sine of 45 over 4, which we just worked out. So then what I'm going to do is I'm going to say the sine of ABD is equal to 6, because I'm bringing the 6 across, 6 sine 45 over 4. And then I still need to find what that ABD is. And to find ABD, I'm actually going to go inverse sine, and I'm going to apply this part here. But I'm going to take my calculator and assist you with this. So I go shift sine, fraction button, 6 times sine 45 over 4, close bracket. And what do we get? Ooh, is there an error? Okay. So what that means, everyone, sorry, Irene and Kimmy. So if there's an error, it means that this triangle isn't possible. And so there must be an error with the question. But my apologies for that. But the main idea I want to take from it is, can you see how if the numbers, so the numbers are obviously correct, incorrect. These triangles are not possible. But I just wanted to make sure you understood the logic of what I was trying to do. I was trying to find this. So let's assume, say, for example, this looks like it's about 50 degrees or something. Then if I knew what that was, this would have to be 85 degrees. And now, because I figure out what that angle is, I can finally use my cos rule. But there was obviously a problem with the question. Okay. Give me a thumbs up if you can follow what I was trying to do by finding the 4. And then after finding the 4, trying to figure out this, and then go to there. But if you felt a bit lost, I don't want you to feel too bad, because yeah, the question had a bit of a problem in it. Okay. Let's go and look at one more question. If there was all you would do for Tejo is you would just write what I did there, and then you would stop and say an error, and you'd get full marks. Okay, let's try one more. And this is from a past exam paper. And we're going to end tonight with this question. We're going to go out with a bang here. So I want you to, let's just see what we've got here. And then I'm going to find CD. Okay. Now I'm starting to combine things here. You are given this triangle, and step 1 says, find BD. Second question says, find CD. Now, you don't just have to use the cos rule now. You can use any of the tools we've learned about. And so maybe somebody can give us some tips in the chat about how they would go about finding BD and how they would go about finding DC. Who feels like they have a tip for us about how to find BD? Maybe someone can even come on and just give us an audio tip. Kevin says, use the sine rule for BD. Kevin, I think I agree with you, because I see the matching pairs. Like I see the side and the angle, and I see this angle, which is opposite the side. What I don't see is where two sides are the included angle, which is like the trademark of the cos rule. And so I think you're onto something trying to find BD using the sine rule. Oh, you could find this angle in, yes, you could, but I don't think it's necessary right now. Yeah. So I'm going to say BD over the sine of 109.16. And then I'm going to say 90.52 over the sine of 31.23. And then I want to know from everyone, what is the value of BD that you're getting? What is the value of BD that you're getting? So I guess I want to move this whole thing across. So I'm going to get what's that value going to be? I can put this in my calculator if I want. I can go fraction 90.52 times sine 109.16 over sine 31.23. And then I'm going to go equals. And it looks to me like BD should be 164.92. So I'm going to say that this side over here is 164.92. I want you, so that is what BD is. To finish today, what is the value of CD going to be? And what tool should we use to find CD? So we just worked out that length there. And we have this length here. What should we use to find CD? And it's the cos rule. Yep, I agree. And now it's over to you to find me. What is the value of CD? So I guess all cos rules have a squared something. And going to be a little bit messy because I've got some decimals. So that's 164.92. That's 235. I could put 235 or, yeah, I'm running out of space. Do you get what I'm trying to do? 164.92. And then here would be 235. And then here would be 48.88. And then from there, I need to find what CD is. Okay, so I need to be careful with my calculator here because there's the potential to make a silly mistake. So 164.92, and then I use the square button, plus 235 with the square button, minus 2 times 164.92 times 235 times cos of 48.88. That's not my final answer. I still have to go square root of the answer. And I should get 177.34 centimeters. And so this would be 177.34. Oh, sorry, not centimeters, it's meters. So it would be meters. Okay, so in the second half of the lesson, what I try to do is show you how the cos rule can be used as part of solving triangles, but where we mix in the sine rule as well. Cool. Okay. Cool. All right. If we could, Kia, if we could put the link to the quiz in the chat. But yeah, if we could put the link to the quiz in the chat. And then are there any final questions before we finish off today? How did you guys feel about today? Did you feel like you could combine the two rules together? Was that starting to happen for you? For those who are new tonight, if it's your first lesson, remember this is lesson 4. And so it would really benefit you a lot to go back and look at the sine rule lesson, the area rule lesson. Okay, so Letty, what I'm going to suggest is tomorrow, the recording will be available by tomorrow. And what I want you to do is take some time to just watch certain parts of the recording again, and you will find with time, the ideas will make sense. The first half of today's lesson was around finding a side using the cos rule. The second half of the lesson was around combining an old tool called the sine rule together with the cos rule. Okay. Yeah. So the reason we made it a bit more confusing in the second half is we wanted to push the level up a little bit. Yeah. All right. Cool. Glad to hear that, Letty.